All right, let's take a look at question 28. So this is a very high mark question we're getting right towards the end of the paper in the 2024 Advanced Maths paper. This is worth 7 marks, and this is one of the trig questions. We are told Anna is sitting in a carriage of a Ferris wheel, which is revolving. The height is given by the formula, where t is time in seconds after it reaches the bottom of the revolution. After it first reaches the bottom, c and k are constants. The top of each carriage reaches a greatest height of 39 meters and a smallest height of 3 meters. Find the value of c and k. Okay, so for part A, we have some function a t is equal to a constant c minus k times cosine of pi t on 24. We're told the max is 39. Max is 39. And we're told the minimum value is 3. Min is going to be 3. Now the c value is going to be the value exactly halfway between these, because this is a shifted negative cosine. So if we draw a little graph like this, it's centered at c. It's a cosine, but it's negative, so then this oscillates like this. So the min will be c minus the amplitude. The max will be c plus the amplitude. So if we can find the difference between max and min, half of that, that's going to be the amplitude. And it's also going to give us c. So the max minus the min is 39 minus 3. That's 36. So 36 is the total amplitude here. Divide that by 2. This gives us 18. So 18 is the amplitude, so therefore k must be equal to 18. Now, if the amplitude is 18 and the lowest point is 3, the c value, the line about which this revolves, must be 21. 21 minus 18 would give you 3. 21 plus 18 would give you 39. So therefore, the c value is 21. So we have found 2 of the parameters in this formula. So for part B, we now have the equation a of t is equal to 21 minus 18 times cosine of, let's write this as pi on 24 times t. It tells us how many seconds does it take for one complete revolution of the Ferris wheel. The question tells us that t is time in seconds, so we don't need to worry about conversions. We just need to worry about the period, right? One full iteration of the cosine function will correspond to one revolution of the Ferris wheel. So the b value in this equation is going to be pi on 24. This is not the period. This is the number associated with the period. The period is going to be 2 pi divided by b. This is going to be 2 pi divided by pi on 24. Pi's cancel. We have 2 divided by 1 on 24. That's 2 times 24. That's 48. So a full revolution of the Ferris wheel is 48 seconds. Okay, so the high mark part at the end, part C. We're told Billy is in another carriage. The height bt in meters above the ground, the top of her carriage is given by this particular formula. C and K are the same in A. During each revolution, there are 2 occasions when Anna and Billy's carriages are at the same height. At what 2 heights does this occur? All right, well, we know that Anna's carriage, Anna, yeah, I've got that name right. Anna's carriage follows the formula A of t is equal to 21 minus 18 cosine bracket pi on 24 times t. We're told Billy's carriage follows the formula B of t is equal to, this is still 21, still the same Ferris wheel, minus 18 times cosine, but it's time shifted. So she has pi on 24 t minus 6. Now, if you think about this, if the rotation period is 48 seconds, we could draw a circle of this. This is both 0 and 48. This is 24. This is 12. This is 36 if we're counting around the wheel. This is the number of seconds it takes to get around. This is 6. Now, geometrically, what this tells us, this is a 45-degree angle. Because this t is shifted by 6 seconds, this means the two carriages that Billy and Anna are in are 45 degrees apart. So what we are trying to find is the question tells us to find the heights that this occurs at. So it'll occur when they're both very close to the bottom down here, and it'll occur when they're both very close to the top up here. Now, notice these heights are equidistant from the central line. So we only need to find one of them, and then that's going to give us both of them, right? One of them will be 21 plus the distance we find. One of them will be 21 minus the distance we find, depending on how we find that distance. So these are our functions. This is our shift. We know what's going on here. So let's think about this mathematically. Let's try and evaluate this function to find particular heights. So let's rotate this wheel a little bit. Let's draw our template wheel again. We know because they are 6 seconds apart, they're 45 degrees apart, one of the instances will occur when t is 3. So after 3 seconds, this will be the equivalent of 45 seconds, they'll be at the same height. And then the other one will occur 3 seconds shy of 24, which will be at 21 and 27. Now we have t minus 6 for Billy. We need to work out who is in which position, because once we know who is in which position, we can just plug in the time. We can just plug in t equals 3 and t equals 21, and that's going to give us what the two heights are. And in fact, we only need to do one of them, right? If we can work out who is to the right and who is to the left. So the question told us that the formula we initially got was height in meters above the ground during each revolution 2 occasions. The original question told us the wheel is rotating counterclockwise. So counterclockwise. So given that Billy's formula is shifted by 6 seconds, this is a minus 6. If we drew both of these cosines, Anna's looks like this. Minus 6 shifts the whole thing to the right. So Billy actually starts slightly high and then goes down. So when Anna is at the bottom, Billy is already slightly in the air and then comes down. So that means this 3 value, this is going to be Anna at the point where they are both equally high off the ground at the bottom level. So we can just evaluate Anna's function when t is 3. So a of 3 is equal to 21 minus 18 times cosine of pi on 24 times 3. So 24 and 3, these cancel. This is pi on 8. We're told 2 decimal places. So we'll put this into our calculator, a of 3. And we have to be careful that we're using the right mode here. This is radians. So we've got to put our calculator, shift setup, put it into radians. We have 21 minus 18 times cosine of pi on 8. My calculator is telling me that this is 4.3701 dot dot dot. So this is the first height where they are both at the same level. And to 2 decimal places, this is 4.37 bracket 2 dp meters. Now the distance between 4.37 and the 21 line is the same as the distance between the 21 line and the top intersection, because the Ferris wheel is just a circle. So this is the first time. The second time is going to be A of Anna is ahead. So this would be Anna, A of 27, which we know is going to be, we need the distance between these two. So this will be 21 minus 4.37. This is the distance, plus 21 minus 4.37. That added to 21. So this will give us a value of 37.63 bracket 2 dp meters. So this was one way to do this question. This way was actually much easier than some of the other ways you could have done it. You could have done it with a whole heap of algebra. You could have done trig functions, set them equal, solve. You could have done trig derivatives to think about tangents and all of that. If you just knew the geometry of a circle, you had a much easier way of doing it, right? Because you knew that they were 6 seconds apart, and because you knew the period was 48 seconds, that was 45 degrees. And that told you what two shapes corresponded to the points where they were equidistant from the ground. So if you're clever about these questions, you can get them done with relative ease. If you do it the long way, the working is much, much harder. And in the marker notes actually solve this out by setting the internal parameters equal to one another, solving the first t value, solving the second t value, which is great, right? That's a great way of doing it. But you do have to make sure that the t values you're getting are the right t values there, right? So there's a lot of slightly more challenging working in those questions. Then the evaluations at the end are easier. In this question, you were just relying on your understanding of geometry, right? Not very complicated geometry as well, quite simple geometry. But this is a fairly hard question. That's why it's worth 7 marks.